Hi, I'm Maddie, and today we're going to talk about the particle-wave duality of light. So welcome to ScienceSideUp, and get ready to fire those photon cannons. Also, this is Toby, and Toby says hello. So if you're interested in science and physics, you've probably heard at some point light can be both a particle and a wave. This is called the particle-wave duality. And when it's a particle, we call it a photon. If it's a wave, it's broadly an electromagnetic wave. And I want to talk a little bit about how both of those things can be true at the same time, because I think that can be a little confusing the first few times you hear it. So to get at that, we're going to go through a thought experiment that we're going to borrow from Isaac Asimov. If you don't know who he was, a science fiction writer, but also a real-life physicist. And so some of his writings on science are really lovely and clear. When Isaac Asimov explained the particle-wave duality of light, he went about it this way. He said, I want you to think about a traffic cone. So I'm going to try to draw one. There, that's kind of like a traffic cone, right? And now I want you to imagine what this traffic cone looks like to a two-dimensional person. So we'll call this guy Timmy here. And if Timmy looks at that traffic cone, what he is going to see is a triangle. That's all well and good, but if we have somebody looking at it from the top or the bottom, so we'll put another little stick person here. We'll call her, I don't know, Sarah. If Sarah looks at the traffic cone, what she is going to see is a circle. Right? She sees a circle. And then if we put Timmy and Sarah in a room together and had them talk about this object that they saw, they would argue a whole lot, right? Timmy would say, it's so obviously a triangle. Look, it has a base and a height, and we can measure the three angles. They all add up to 180 degrees. It's very, very clearly a triangle. And Sarah would say, I'm a little concerned that you don't know what a triangle is because this is a circle. It's round, it has a circumference, there's no sharp corners, and neither of them's wrong, right? They can both prove their points, which is kind of the baffling thing. If we think about which of them is right, well, neither of them's right, but neither of them's really wrong. Right? They're talking about a three-dimensional object and they're two-dimensional beings. So they are limited in what they can perceive. So is light a particle or a wave? Well, it's neither. It's something bigger and more complicated than we are able to perceive. You and I experience the world in mostly 4 dimensions, 3 spatial dimensions, and then time. But the universe actually has somewhere between, I think, 11 and 21 dimensions. And so what light is this higher dimensional object, and we're only ever seeing a part of it depending on how we look at it. And so if we look at it one way, we see a particle, we see a photon, that you can measure its energy and momentum, and sometimes in some applications it's beneficial to look at photons. But in other applications, like glasses, right? A wave is a much more useful way of looking at light, because we can talk about laws of optics and how to bend light so that we can see properly and all of that. My goodness, Tobes. Toby very much wants to help. That or he wants his dinner. I'm not quite sure. But that's just a primer into the particle-wave duality of light. Is light a particle or is it a wave? Well, it's neither, and it's also both. Really, it's something more complicated that we can't perceive. And that's okay, right? It's okay for things to be more complicated than we can understand right now. And so that is, in a nutshell, the particle-wave duality of light. I hope you enjoyed this video. I hope you enjoyed meeting Tobes. Like and subscribe, and I will hopefully see you back soon. All right.